When the cloud failed and 3I Atlas bent toward us hook, at 3:11 in the morning on October 20, 2025, the green monitoring wall in a glass-walled operations room in Northern Virginia went from mostly calm to almost entirely red. A senior incident manager for a major streaming platform, Daniel Price, watched as latency graphs spiked and authentication failures rolled in. His company lived on AWS US East 1. Within minutes, login pages across the eastern United States hung on spinning wheels, smart TVs froze mid-scene, grocery delivery apps refused to load. Thousands of engineers like Price refreshed dashboards, joined emergency calls, and typed the same question into private Slack channels: is it us or them? At that same moment, in a darkened control room at the Goddard Space Flight Center outside Washington, D.C., another screen flickered with a very different kind of anomaly. A team led by orbital dynamicist Dr. Rachel Morales was running an overnight fit of trajectory data for a recently discovered interstellar object informally dubbed 3I/Atlas. It was supposed to be on a clean hyperbolic path, another fast visitor like Oumuamua or 2I Borisov. Instead, the latest residuals showed a subtle but consistent departure from the expected track. When Morales overlaid the updated solution on the galactic map and extended it forward in time, the thin white arc that represented 3I/Atlas brushed uncomfortably close to the region of space occupied by Earth's orbit. For a few seconds, nobody said anything. The keyboard clatter stopped, replaced by the soft hum of air conditioning and a distant coffee machine. Two very different systems, one digital, one celestial, had twitched at nearly the same moment. In a world that now treats coincidences with suspicion, it was enough to plant a seed. Why, within the same 24-hour window, did a core cloud region stumble while an interstellar object appeared to nudge onto a course that might, in some projections, graze our own backyard? For an ordinary user, the outage was just an annoyance and a meme template. For Morales and a small circle of astronomers, the updated orbit plot was something else entirely, the beginning of a problem they were not sure how to name. Over a span of days in late 2025, a rare interstellar object called 3I/Atlas appeared to change its course in a way that, under certain models, brought its future path uncomfortably near Earth's orbit, just as a major incident rippled through AWS US East 1 cloud region. This first part traces the discovery of 3I/Atlas, the architecture of the cloud that briefly failed, and the timeline that binds them together, before mapping early data, voices, and scenarios that will shape how the story unfolds. Background: interstellar objects are, by definition, visitors. Our own solar system is full of debris, asteroids, comets, dust, but 1I/Oumuamua, discovered in 2017, was the first object ever recognized as coming from beyond our Sun's gravitational family. 2 years later, 2I Borisov followed, a more classical comet with a clear coma and tail. Both moved on hyperbolic paths, in and then out, their velocities too high to be captured. 3I/Atlas, picked up by the Atlas survey in mid-2025, looked at first like a cousin in that sparse family, faint, fast, and on a trajectory that, when traced backward, originated in the galactic halo rather than any known local reservoir. For the public, those earlier visitors were curiosities. For planetary defense offices, they were a reminder that the galaxy doesn't end at the Oort cloud. 3I/Atlas came with its own oddities. Early photometry suggested an object with a relatively high albedo and muted color, more neutral than many comets. Spectroscopy using JWST in September and early October produced a surprising ratio of CO2 to H2O in its outgassing, CO2, H2O around 8:1 with a margin of error of about plus or minus 1, significantly richer in carbon dioxide than typical solar system comets. Polarimetric observations from ground-based telescopes hinted at an inversion angle near 17 degrees, another deviation from familiar profiles. To a lay reader, these numbers might sound abstract. In practice they mean this: 3I/Atlas looked like it carried a surface and coma chemistry not well represented in our current catalogs. Unusual composition does not imply intent. Most working scientists repeated that caveat. but the data pegged it as an outlier. On the other side of the story sits AWS US East 1, the cloud region that many people never think about but whose failures they feel immediately. US East 1 is not a single building but a cluster of availability zones spread across parts of Northern Virginia, hosting everything from tiny personal websites to critical enterprise backends. DNS resolvers route users to endpoints there, identity services verify who you are, databases like DynamoDB store and retrieve the structured data behind timelines, carts, and balances. If the global economy has a set of digital arteries, US East 1 is among the thickest. When something goes wrong in that region, whether a misconfiguration in the control plane, a cascading hardware fault, or a software bug in a routing service, users around the world see the symptoms as if they were weather, suddenly, and all at once. Under the Atlantic, parallel systems carry our traffic between continents. Submarine cables like AAE1, CIOS, or Italy-Greece related links are physical fibers that hug the seafloor, periodically checked with optical time-domain reflectometry and repaired by specialized vessels when their glass cores are nicked, crushed, or cut. Most of the time, automated routing diverts around local trouble. A break in one cable is a bump, not a catastrophe. Only when multiple weak points line up, an overloaded cloud region, rerouted traffic, subtle bugs in recovery logic, do real outages emerge. Overlaying this infrastructure is a culture of watching. Social media platforms and alternative media channels take every technical burp and every strange astronomical plot and remix them into narratives. After Oumuamua, hashtags like #AlienProbe and #NotJustArock became a shorthand for those who wanted more than a natural explanation. By 2025, live-streamed telescope feeds, citizen science neutrino alerts, and real-time cloud status trackers had woven themselves into that fabric. A faint spectrum line or a transient spike in error graphs no longer stayed confined to lab notebooks and internal tickets, they became screenshots, threads, and, for better or worse, stories. Timeline: the chain of events that brought 3I/Atlas and the US East 1 incident into the same frame begins months before that October night. On July 1, 2025, the Atlas survey in Hawaii flagged a faint, fast-moving object with a highly eccentric orbit. Within days, follow-up observations confirmed it as an interstellar candidate and it was provisionally tagged 3I/Atlas. Through July and August, ground-based telescopes refined its orbit and basic properties, while initial JWST observations were scheduled and granted high priority due to the rarity of such objects. On September 19, 2025, the IceCube Neutrino Observatory recorded a high-energy neutrino event, catalogued internally as 2550919A, with a reconstructed direction that, within error bars, loosely overlapped the region of sky where 3I/Atlas had been observed days earlier. The coincidence was noted but not treated as significant at the time. Between late September and mid-October, JWST carried out a series of spectral observations of 3I/Atlas, producing the unexpected CO2-rich profile, while ground-based polarimetric campaigns logged data indicating an inversion angle of around 17 degrees. On October 18 and 19, Morales' team at Goddard processed new astrometric measurements and began to see small but systematic residuals when fitting a simple gravity plus outgassing model to the object's path. At 3:11 Eastern Time on October 20, monitoring systems for AWS US East 1 registered a sharp spike in DNS next domain responses and rising authentication latencies, triggering incident tickets across multiple large customers. By 3:20, user-facing services in parts of the US and Europe experienced errors, while AWS' own status page lagged behind internal alarms by critical minutes. Over the next 6 hours, engineers rolled back configurations, shifted traffic to other regions, and issued standard root cause language that would be parsed and debated for days. On October 21, updated orbital solutions for 3I/Atlas incorporating the latest data indicated a slightly different asymptotic trajectory. Under some extrapolations, the extended path now skimmed within a few astronomical units of Earth's orbit over longer timescales, tightening the object's relationship to our neighborhood in a way that some team members found statistically unnerving. On October 22, the International Astronomical Alliance's public office issued a brief statement acknowledging ongoing refinement of 3I/Atlas's orbit and urging caution in interpreting early trajectories. On October 23 and 24, internal memos began to circulate among U.S. agencies and major observatories, asking for cross-checks, independent orbital fits, and careful correlation studies between the cloud outage and the astronomical data, not because anyone had a mechanism in mind, but because the dates lined up and the questions, inevitably, would come. Data blocks. Inside these dates, the numbers that drove concern and skepticism sit like small anchors. JWST's spectra of 3I/Atlas, acquired between September 28 and October 10, yielded a CO2-H2O ratio near 8:1 with an uncertainty of plus or minus 1. For most comets in our catalog, water dominates. Carbon dioxide is present but rarely leads by such a margin. This unusual chemistry suggested either an origin in an environment with different volatile inventories or a surface that had undergone processing far from the familiar thermal histories of our own outer system. Polarimetric measurements from several mid-sized observatories reported an inversion angle around 17 degrees, a value at odds with the typical 20 to 23 degree range seen in many dust-dominated comets. Polarization tells astronomers about grain size, structure, and composition. A lower inversion angle can point to exotic mixtures of ice and dust or irregular aggregate particles. A smaller subset of spectral analyses, mostly from instruments not designed for precision line work, claimed to see faint emission features that could align with nickel alloy lines. These unverified metallic signatures appeared in a handful of preprints and blog posts, always with caveats about signal-to-noise and calibration. So far, no major observatory had confirmed them, and most senior spectroscopists urged restraint. On the infrastructure side, internal AWS logs that later leaked to a limited circle of customers painted a picture of a cascading but mundane failure. Log, October 20, 2025 T3 hours 9 minutes and 58 seconds Z control plane SVC config, push_failed auth, cluster AZ3, lock weight exceeded. Log, October 20, 2025 T3 hours 11 minutes and 7 seconds Z DNS resolver US, East, 1, next domain rate 98%, upstream auth latency 1.4 s, DynamoDB timeouts 504 in multiple shards. Log, October 20, 2025 T3 hours 14 minutes and 33 seconds Z LB Health Checker, unhealthy backend pool threshold exceeded, initiating drain, spillover to us, west, 2 initiated. Taken together, the entry suggested a mistimed configuration change that clashed with existing lock conditions in an authentication database, which in turn cascaded into name resolution failures and unhealthy load balancers. Forensic teams saw no obvious signatures of malware or anomalous API calls from unusual locations. Still, the overlap in timing with broader network reroutes drew attention to undersea cables. OTDR traces from an earlier March 7, 2025 event on AAE-1 had shown a classic sharp reflection at 124.3 kilometers from shore, indicative of mechanical damage consistent with an anchor drag rather than a precision cut. That incident had forced traffic to flow through alternate paths, leaving some systems more sensitive to regional overloads months later. In this sense, the October 20 cloud incident was the visible tip of a longer, slower accumulation of risk. A single tweet captured how these technical threads and skyward anomalies began to blur in public imagination. Tweet at @astro_watch October 21, 2025 9:12 Eastern Time, 3I Atlas behind the sun window about to start. Meanwhile at AWS US East, 1 just choked. 2 blind spots in 24H. Coincidence or just our brains looking for patterns? #3I Atlas. Voices. Within hours of the incident and the orbital update, a small chorus of experts and near-experts began to shape the early narrative. From a dynamical standpoint, a small adjustment in the inferred path of an object like 3I/Atlas is expected as we get more data, said Dr. Rachel Morales in an internal email later quoted. With her consent, in a trade publication. The question is not whether the orbit changed but how much our model did. We have to separate the math from the fear. Her tone, colleagues said, was cautious but not dismissive. In Seattle, cloud reliability engineer Michael Chen was blunt in a private customer briefing that quickly leaked. "We don't see any indicators of compromise," he told a room of CTOs over video. "This looks like a bad deploy plus some unfortunate timing with existing load on critical services. If someone wanted to tie this to a comet or a neutrino, I'd gently suggest they focus on their rollback strategies first." In Washington, an unnamed official at a U.S. security agency offered a different emphasis during an off-the-record conversation with a journalist. "We have a protocol now," the official said. "When you have an interstellar object with unusual properties and any concurrent anomalies in critical infrastructure, we at least ask if there's a common cause or a potential exploitation of the moment. That doesn't mean we think a rock is hacking the cloud. It means adversaries read the same headlines you do." On the fringes, alternative media hosts seized on the metallic line rumors. "If the spectra are real, we're not just talking about ice and dust," argued podcaster Lena Grace on her late-night stream. "We're talking industrial fingerprints, nickel alloys, engineered surfaces. And right when that's bubbling, the main cloud region goes down? Come on." Yet even she stopped short of explicit claims, perhaps wary of being written off as pure sensationalism in an environment now crowded with amateur data analysts. The International Astronomical Alliance struck a more measured note in a brief press release. Press, IAA October 22, 2025, current polarimetric data on 3I/Atlas showed deviations from common cometary profiles. These deviations are under active study. We urge communities, including non-professional observers, to refrain from drawing premature conclusions about origin or intent. The words, origin or intent, were doing a lot of work in that sentence, acknowledging, without endorsing, the questions people were already asking. Scenarios, by the end of October, for main explanatory frameworks had crystallized in the minds of those trying to make sense of the overlapping events. Scenario A was simple coincidence. In this view, 3I/Atlas is an unusual but natural interstellar object with odd chemistry and polarization, and US East 1 suffered a garden-variety configuration-induced outage at an unlucky moment. Timing, plausible, given the sheer number of complex systems operating at any moment. Means, trivial, no causal connection needed. Motive, not applicable. Scenario B treated the cloud outage as an opportunistic exploit layered onto an otherwise natural astronomical event. Here, 3I/Atlas remains just a rock and ice mixture, but a human adversary, state or non-state, used rising public attention on the object as cover to probe or disrupt a key cloud region, knowing that confusion would be higher. Timing, the close coincidence is a feature, not a bug. Means, technically feasible for advanced actors. Motive, testing capabilities, sowing doubt, or signaling power. Scenario C inverted the emphasis, the cloud incident as a pure technical accident, but 3I/Atlas as something more than natural. Under this narrative, the unusual CO2 dominance, odd polarimetry, and disputed metallic lines hint at technological modification, with the subtle change in inferred trajectory reflecting controlled or at least non-gravitationally trivial forces. Timing, the overlap with the outage is incidental but narratively potent. Means, beyond current human understanding. Motive, unknown or speculative, from passive probe to indifferent relic. Scenario D tried to stitch both domains together physically, positing some as yet unknown coupling between interstellar visitors and near-Earth technological systems, exotic particles, focused emissions, or other mechanisms that could influence electronics or networks. Timing, the wow factor scenario. Means, currently unsupported by any robust evidence, the IceCube neutrino event, while temporally and directionally intriguing, sits well within expected background. Motive, again entirely conjectural. Among working professionals, Scenario A, coincidence with unrelated but interesting anomalies, held the default spot, not because anyone found it thrilling, but because it required the fewest new assumptions. Yet even those who favored it admitted that human pattern finding would not let the other scenarios simply fade. Policy and infrastructure implications. Even in this first phase, before any classified briefings or emergency sessions, certain lessons were already emerging. Cloud providers and their largest customers faced renewed pressure to reduce single-region dependencies, to treat U.S. East 1 not as a default but as one of several equal peers. Multi-region and multi-cloud architectures had been recommended for years. The October outage gave those slide deck bullet points fresh urgency. Network operators revisited the health of submarine cable redundancy, reviewing OTDR reports and maintenance logs not just as engineering paperwork but as a part of systemic risk assessments that now included geopolitical and even soft, psychological dimensions. How would the public react if multiple layers failed while the sky was, quite literally, doing something strange? Scientific institutions, for their part, were reminded that open data cuts both ways. Releasing preliminary spectra and polarimetry for 3I/Atlas helped accelerate crosschecks and independent analysis, but it also fed rumor mills hungry for anything that could be packaged as a revelation. There were quiet discussions about graduated disclosure, about how to label data as preliminary, uncalibrated, or unverified, in ways that survived the journey from a FITS header into a screenshot on a social platform. At the policy margin lay a set of deeper questions: whether international bodies should maintain a standing, no-reply, stance regarding any technological interstellar signatures, and whether events that touched both space and core infrastructure ought to trigger automatic, multi-agency reviews, even when initial evidence pointed to coincidence. Conclusion: open in the days after October 20, 2025, the outage logs and the orbital plots began to drift apart again in professional conversations. Cloud incident reports turned into internal action items, bug fixes, and promised architectural improvements. 3I/Atlas, sliding slowly toward a period of solar conjunction that would hide it from most instruments, retreated into the narrow world of orbital fitters and spectral modelers. Yet the echo of that one early morning window remained, a glowing wall of red in a Virginia control room and a thin, pale arc on a galactic map in Maryland, both demanding interpretation. For some, the story was already over, a rock on a complicated path and a cloud region that tripped over its own complexity. For others, especially those who stared at the CO2-H2O ratio, the inversion angle, and the unresolved residuals in the trajectory fits, the story had barely begun. They knew that the next weeks would bring more data, more chances to be wrong, and more pressure to be definitive. At least two interpretations would stay on the table for now: that 3I/Atlas is a strange but natural messenger from elsewhere, whose apparent bend toward our orbital lane is nothing more than the universe reminding us how small our sample size still is, or that it is something rarer still, an object whose properties and path hint at technologies or processes not yet in our textbooks. Between those poles lies the practical problem that this series will follow: how a species that routes its lives through fragile clouds and stares at rare lights in the sky decides what to believe when two very different systems flicker at once. Appendix: Technical note: key working figures as of late October 2025 included 3I/Atlas JWST derived CO2-H2O is almost equal to 8:1 plus or minus 1, polarimetric inversion angle is almost equal to 17 degree, preliminary, unconfirmed reports of nickel alloy emission lines in low SNR spectra, AWS US East. One incident window centered on 2025-10-20T03:11 ET with DNS next domain spikes and DynamoDB 504 timeouts. Prior AAE-1 cable damage localized by OTDR to -124 km offshore in March 2025. And IceCube event 2550919A, -290 TeV, with sky localization overlapping, within several degrees, the late September position of 3I/Atlas. How these numbers are weighed, and by whom, will shape everything that follows. When the sky became a question, the first week of November 2025 opened with Washington air sharp and dry, the sky over the National Mall unusually clear for that season, a small irony not lost on the reporters queuing outside the Capitol complex. Inside, the Senate Committee on Science and Infrastructure convened a joint session with NASA, the Department of Commerce, and AWS executives. The title on the agenda was neutral: Recent Astronomical and Infrastructural Events, Review and Coordination, but everyone in the room knew what it meant. They were there to talk about 3I/Atlas and the outage. Cameras rolled as Senator Caroline Hughes opened with a line that would become the quote of the day: "When two blind spots appear at once, one in the sky, one in our networks, it's our duty to ask what we're not seeing." Behind her, screens displayed side-by-side visuals: the plotted orbit of 3I/Atlas, its projected path brushing Earth's orbital lane, and a map of AWS regions pulsing through shades of yellow and red. On another floor, journalists live-streamed snippets, while online forums filled with theories faster than moderators could prune them. The hearing began with data. Dr. Rachel Morales, still jet-lagged from Maryland, delivered a calm, methodical summary of her team's findings. She explained the astrometric fits, the CO2-H2O ratio, the inversion angle. "We have no evidence of non-natural acceleration," she said. "The small deviation observed can be explained by asymmetric outgassing or radiation pressure. Its approach distance remains in the order of astronomical units, far beyond any hazard radius." Senator Hughes leaned forward. "So it's not coming here?" Morales smiled politely. "No, Senator. Space is vast. Close in astronomical terms doesn't mean close in human terms." When she finished, AWS Vice President Michael Chen took the microphone, reading from a prepared statement. The October 20th event was caused by a mistimed configuration propagation leading to authentication latency and DNS resolution failures. There is no indication of external interference. His language was technical, precise, and utterly unhelpful to anyone craving meaning. Yet as the testimonies piled up, so did unease. Each expert spoke in disclaimers: no evidence, no link, no cause beyond known mechanisms. But outside that room, the narrative had escaped containment. On social platforms, hashtags #blindwindow and #3iShift trended for days. YouTube creators uploaded hour-long analyses claiming hidden alignments between the object's trajectory and terrestrial energy grids. Memes juxtaposed AWS logos with comet tails, captioned, "When your backup plan is cosmic." Mainstream networks tried to strike balance, quoting scientists and then giving airtime to independent analysts who asked whether coincidences could ever really be random. Public opinion fractured along predictable lines: skeptics dismissing hysteria, believers citing patterns, the majority simply confused. The White House issued a short press release reaffirming confidence in NASA's findings and thanking AWS for swift resolution and transparency. The brevity was strategic: too many words would feed speculation. In Europe, the European Space Agency held its own briefing in Darmstadt. ESA Director of Science Dr. Helene Dubois presented their independent orbital analysis, confirming that 3I/Atlas's closest approach remained more than $0.20 away. "This is not a collision course," she said in English and then repeated in French. "It is a scientific opportunity." But even as she spoke, reporters pressed about trajectory change and unexplained flare. Dubois sighed: "When you watch a car from far away and it seems to change lanes, sometimes it's just the angle of your view." Across the Pacific, the Chinese National Space Administration released a technical bulletin, translated hours later by Western outlets. It confirmed observation of the same CO2-rich spectrum and noted small irregularities consistent with outgassing, adding a subtle line: "Continuous monitoring recommended." That phrase, neither alarming nor reassuring, circulated as evidence of hidden concern. The UN Committee on the Peaceful Uses of Outer Space, COPUOS, called an emergency video session on November 5. The transcript later leaked, delegates debated whether interstellar objects with non-standard behavior should trigger automatic multinational reviews. The U.S. delegate argued for scientific caution, the Russian delegate suggested greater transparency in data sharing. The meeting ended without resolution, but it planted the idea of a new protocol, an interstellar event framework, for future cases. Think tanks weighed in. The Atlantic Science Forum published a white paper titled Dual Domain Fragility, Lessons from 3I/Atlas and U.S. East 1. It argued that society had reached a point where physical and digital systems were so intertwined that simultaneous disruptions, however unrelated, would always create informational crises. We cannot separate sky from cloud, the paper stated. Trust is the shared substrate. Another analysis from the RAND Center for Space Policy warned of narrative contagion, defining it as the spread of uncertainty faster than any verifiable fact. Meanwhile, markets reacted in small but visible ways. AWS parent company stock dipped 2% after rumors suggested a classified link between the outage and space weather interference. Telecommunications firms quietly commissioned resilience audits. Insurance underwriters added cosmic risk coincidence clauses to some cyber policies, a legal absurdity but a profitable one. In the media ecosystem, the story evolved into spectacle. Morning shows interviewed astrophysicists alongside cybersecurity experts. Late-night comedians joked that aliens tried to log in but forgot their password. But beneath the humor ran a current of genuine unease. If our most advanced systems can falter without clear cause, what else could? On Reddit, a thread titled, "If 3I/Atlas isn't natural, do we reply?" reached 500,000 comments before moderators locked it. The debate was philosophical, not scientific. One user wrote, "If it's a probe, maybe it's just listening. Maybe the outage was us being heard." Another replied, "Or maybe it's us breaking our own toys and pretending the sky blinked." Among professionals, fatigue replaced curiosity. Scientists fielded the same questions on repeat: is it coming closer? Is it artificial? Did the neutrino mean something? They answered no, no, and no. Yet every no seemed to generate two new maybes. On November 8, the International Astronomical Alliance released an updated trajectory bulletin. Current models place 3I/Atlas's perihelion at 73 cents with ejection toward galactic longitude 125 degrees. No Earth intersection within projected uncertainty bounds. The key phrase was, within projected uncertainty. Statistically trivial, but enough to keep debate alive. The media latched onto the uncertainty bounds, as if it were a confession. Citizen scientists continued observing. Using telescopes in Chile and the Canary Islands, they detected a faint reappearance of 3I/Atlas's coma emerging from solar conjunction earlier than predicted. Some claimed this indicated acceleration. NASA clarified that the early reappearance was due to favorable geometry, not motion. But images of a brightening spot against the black sky circulated faster than corrections. At a public Q&A hosted by the American Museum of Natural History, Morales faced a packed auditorium. Someone shouted, "If it's natural, why does it act different?" She answered softly, "Everything acts different when you look close enough." Her words drew applause and headlines. Still, questions persisted about information control. A leak from within NASA hinted that certain spectral datasets from JWST had been withheld pending further verification. Morales denied secrecy but admitted calibration was ongoing. "If you publish too early," she told a journalist, "you feed myths. If you wait too long, you breed them." Meanwhile, AWS internal review leaked to The Verge. The report confirmed the recursive lock condition as root cause but noted a rare timing coincidence. A database health check had triggered exactly at 3 hours 11 minutes and 7 seconds, the same second the DNS resolver spiked. Engineers described it as a temporal race condition, a computer science term that now sounded almost poetic. Online commentators seized on it, race condition between us and the universe. As the public narrative spun wider, intelligence agencies took quieter interest. A declassified briefing summary noted, no evidence of external interference, but analysts flagged the psychological dimension. Adversaries could exploit coincidence-driven panic to test response systems. Simulated information attacks followed, blending real data with fakes, pushing social networks to near meltdown. Twitter-like platforms saw bots amplify the idea of the comet that talks in code, using strings of binary that, when decoded, spelled nonsense. The disinformation became performance art, but some audiences couldn't tell. In universities, philosophy departments turned 3i/Atlas into case studies on epistemology, how humans assign meaning to randomness. A professor at Stanford coined the term conjunction cognition, our instinct to connect events separated by space but joined by time. His essay, The Universe as Algorithmic Mirror, went viral among graduate students. On November 12, NASA and ESA hosted a joint virtual press conference. The moderator's voice trembled slightly as she introduced the updated images of 3i/Atlas emerging from behind the Sun. The object appeared brighter, its coma more pronounced, its tail slightly kinked. Morales explained that sunlight scattering could produce the kink, not necessarily a course change. We expect to refine orbital parameters in the coming week, she said. When asked if the object's apparent brightness increase suggested activity, she replied, possibly seasonal effects due to rotation. Nothing beyond known physics. But the phrasing, nothing beyond known physics, trended within minutes, quoted as both reassurance and doubt. That same evening, a high-resolution image from the JWST data pipeline leaked to a forum. It showed a faint, linear structure protruding from the object's core, barely above noise. The caption read, "Artifact or appendage?" The leak originated from a subcontractor lab processing calibration files. Within hours, NASA confirmed the image's authenticity but insisted the structure was a processing artifact caused by cosmic ray streaks. Still, headlines screamed, something sticks out of 3i/Atlas. In a crisis of meaning, artifacts became evidence. Internationally, politics caught up. European ministers called for a transparency accord among space agencies. China proposed a shared database for interstellar monitoring. The US hesitated, citing proprietary data rights from JWST contractors. Russia offered to lead an independent verification task force, which Western officials politely declined. The UN issued a non-binding statement urging cooperative stewardship of extraterrestrial knowledge. It read like science fiction bureaucracy but mattered symbolically. Humanity was writing policy for a mystery it didn't understand. In think tank circles, debates turned to ethics. Should we answer if an interstellar object emitted signals? Who decides what constitutes communication? A RAND memo titled "The No Reply Clause Revisited" resurfaced, reminding policymakers that since 1977 the implicit protocol was silence unless consensus existed. Now, consensus felt impossible. Morales, exhausted, withdrew from public appearances. Her last recorded statement came in an interview with PBS, "The danger isn't the object. It's how quickly we fill the unknown with noise." That night, she flew back to Maryland. On the same day, AWS released final remediation measures, staggered config pushes, improved auth failover, and independent redundancy audits. Their press release closed with a curious sentence: "Resilience is the only defense against coincidence." The phrase caught on as a corporate mantra, later adopted by news outlets as a tagline. But behind the scenes, cybersecurity analysts noticed something stranger. During the outage, system telemetry recorded minor discrepancies in time synchronization across NTP servers. Milliseconds out of sync, yet uniformly delayed eastward. The anomaly persisted for only 2 minutes but was documented. Engineers attributed it to network jitter. Others wondered if solar radiation interference might have played a role, though space weather indices remained quiet. For conspiracy circles, this was gasoline. A viral post read, the comet bent time. Fact-checkers debunked it within hours, but virality obeys its own physics. By mid-November, the story had spread beyond science. Artists painted 3I/Atlas as a mirror of human fragility. Economists used it as metaphor for global interdependence. Psychologists studied collective responses to uncertainty. One editorial in The Atlantic captured the zeitgeist: "We saw our reflection in a rock and mistook it for a signal." Yet in quiet observatories, scientists continued working. Preliminary radar echoes from Goldstone hinted at a rough, elongated shape about 300 meters long, rotating every 11 hours. Its surface reflectivity was low but uneven. The linear appendage from the leaked image vanished under better calibration. Still, faint metallic hints persisted in mid-infrared spectra, too weak for confirmation, too consistent to dismiss. ESA's technical note called them statistical curiosities. Morales's team prepared a paper titled Interstellar Object 3I/Atlas, Post-Conjunction Observations and Dynamical Update. It concluded that the object's trajectory had stabilized, its motion remained consistent with non-gravitational acceleration from outgassing, magnitude 2 × 10 m/s superscript 2. In plain terms, small, natural, and harmless. But the public didn't read plain terms. They read headlines. On November 20, as the IAA finalized its bulletin, one sentence leaked early: "Object remains inbound with anomalous light curve modulation pending further analysis." Inbound trended instantly. The word carried weight it didn't deserve. It didn't mean heading for Earth, merely continuing toward perihelion. But context rarely survives virality. Protests sprouted outside NASA headquarters demanding full disclosure. Placards read, "Tell us what you know," and "Stop the silence." Among the crowd were climate activists, tech skeptics, and cosmic enthusiasts, an improbable coalition united by distrust. Inside, Morales and her peers reviewed the next observation window, calculating visibility around December 3. They expected nothing dramatic. Still, the object had become something larger than itself, a mirror for every anxiety about control, technology, and truth. International media dubbed it the messenger that said nothing. On November 25, a classified interagency memo circulated between NASA, DoD, and the White House. It summarized the current assessment: 3I/Atlas exhibits natural behavior consistent with volatile-rich composition. No collision risk. Recommend continued monitoring and coordinated public messaging to mitigate misinformation. The memo's last line was underlined: "Perception management essential to national stability." That same day, a small glitch hit another cloud provider, Google's Europe West 2 region, causing login delays. It lasted 15 minutes, but someone noticed the timestamp, 3:10 Universal Time Coordinated. Posts appeared instantly: "It's happening again." Engineers groaned, astronomers sighed. Coincidence had become contagion. As November drew to a close, the IAA scheduled a global press event to close the case. Morales agreed to speak. On stage, she began quietly: "We've watched an object from beyond our solar system, and we've watched ourselves reacting to it. The data tell one story. Our fears tell another." She presented final graphs, trajectory plots, light curves, spectral ratios. "It will pass by, silent and indifferent," she said. "The universe doesn't send messages, but it leaves patterns. It's our choice how we read them." The audience applauded, subdued. Yet even as she spoke, one more alert hit internal monitoring channels: a minor, unexplained dip in telemetry from a European ground station tracking 3I/Atlas. The signal froze for 90 seconds, then resumed. Engineers blamed a local relay fault. Still, someone whispered, "Again?" The coincidence chain refused to break. The press conference ended. Outside, the sky over Washington darkened early, streaked with contrails glowing orange in the last light. News anchors rehearsed closing lines, scientists confirm no threat, public fascination continues, another mystery resolved, mostly. But on social feeds, one sentence from Morales' speech trended out of context: "It will pass by, silent and indifferent." To many, it sounded like prophecy. The official IAA bulletin published that evening confirmed the obvious: no impact, no signal, no cause for alarm. Yet the closing paragraph hinted at humility: scientific models remain under revision. Reacquisition in December may refine estimates. In those final words, the open loop persisted, a tiny window for the unknown. Across laboratories and data centers, people returned to normal routines, but normality itself felt altered. In the following days, think pieces multiplied. Some praised transparency, others lamented hysteria. The Washington Post summarized it best: "For one strange month, the Earth looked up and saw itself reflected in data." The article closed with a quote from Morales: "We're not afraid of rocks or outages. We're afraid of not knowing which is which." As November 30th dawned, 3I/Atlas drifted behind the glare of the sun again, invisible to all instruments for another week. Servers hummed, lights blinked, the world kept spinning. Somewhere above, a small object from another star moved through space, its course steady, its secrets intact. Whether it was coincidence or reminder, no one could say. The story, for now, remained open, suspended between orbit calculations and human imagination, waiting for December's reacquisition to tell whether the universe had changed, or only our understanding of it. Inside the quiet rooms as December began, the public attention span began to fray, but within sealed offices at NASA Goddard, the Jet Propulsion Laboratory, and the IAA headquarters in Geneva, the investigation had only deepened. 3I/Atlas was again visible, faint but stable, emerging from solar conjunction in the early morning of December 3, 2025. Morales sat at her desk, eyes fixed on new telemetry feeds streaming from the JWST pipeline. The object signal was faint, distorted by residual solar interference, but data reconstruction software slowly filled in its spectrum pixel by pixel. For the first time in weeks, she exhaled without speaking. The numbers stabilized, velocity consistent, magnitude steady, trajectory marginally altered but within prediction limits. Yet the deeper layers of analysis, the kind only internal teams could see, told a more complex story. Within the metadata logs of the JWST calibration runs were small irregularities, time tags offset by 37 milliseconds from expected sequence intervals. It was a trivial drift, but it mattered to those who lived by precision. The first thought was mundane: telemetry desynchronization due to solar noise. The second was unsettling: a faint systemic offset in multiple instruments could imply a calibration artifact or a deeper synchronization error. Morales called a technical meeting. "Let's not jump," she told her colleagues, "but let's check every timestamp, every hash." The room filled with quiet keyboard clicks. Across the country, at AWS headquarters in Seattle, engineers were doing something eerily similar. The October outage had triggered an ongoing internal post-mortem led by Michael Chen's reliability division. Their logs showed the same 3 hours 11 minutes and 7 seconds timestamp repeated across unrelated subsystems. At first it was treated as coincidence. Later, they noticed those identical time codes corresponded to different internal NTP servers that shouldn't have aligned to the same millisecond. A shared clock drift pattern suggested an external offset, possibly due to temporary GPS synchronization lag. To cloud engineers, that was a networking problem. To physicists, it was data worth correlating. One of Morales's analysts, Priya Sethi, noticed the parallel during a late-night Slack exchange. "It's the same offset magnitude," she typed. 37 milliseconds in both cases. Different domains, same direction. Morales frowned. "Correlation doesn't mean causation," she replied. But she couldn't ignore it. She requested the AWS postmortem under a technical collaboration clause, citing potential cross-domain synchronization phenomena. AWS legal teams hesitated, but after a week of back-channel negotiation, they shared anonymized logs. The next 48 hours were consumed by cross-analysis, cloud timestamps and telescope telemetry aligned on a shared time base derived from GPS satellites. A brief solar flare on October 20, recorded as Class C8, had produced a mild ionospheric disturbance. It was enough, perhaps, to disrupt both GPS synchronization and telescope timing, creating the illusion of a link between cosmic and cloud events. That was the working hypothesis, a clean, boring, technical fix. But the problem with boring explanations is that they seldom end stories. Morales wasn't satisfied. The new JWST spectra of 3I/Atlas, reprocessed in early December, contained faint metallic features again. Nickel, possibly chromium, buried in noise but persistent across frames. She double-checked the data pipeline, bias subtraction, flat field correction, cosmic ray rejection, all standard. Yet the features survived every test. She wrote in her log, if artifact, consistent across 2 months and 2 instruments. If real, implies metallic vaporization at 1400 K. Those temperatures suggested recent activity, maybe micrometeoroid impacts or sublimation of embedded minerals. Still, the possibility of something manufactured, however remote, returned. Morales emailed a draft note to the IAA Scientific Council proposing deeper analysis by the Materials Spectroscopy Subcommittee. Within hours, the response came, not from scientists but administrators. Proceed, but refrain from public dissemination until peer review. It was bureaucratic language for wait. In Geneva, IAA Director General Dr. Laurent Favre chaired an internal meeting on December 6. The transcript later leaked anonymously. "We are not suppressing data," Favre said. "We are sequencing release to avoid misinterpretation." One physicist pushed back, "But by the time we finish sequencing, the story will write itself without us." Favre replied, "Then we make sure the story is at least technically accurate." The tension between science and control hardened into silence. Meanwhile, across agencies, hidden conflicts flared. At NASA headquarters, a small task force labeled Sigma, Signal Integrity and Galactic Material Analysis, had formed to handle the Atlas anomaly. Their mandate was narrow: study spectral data, assess compositional hypotheses, but internal emails revealed growing friction. One senior official wrote, "We need coordination with defense intelligence before releasing any reference to metallic lines." Another scientist retorted, "We're not studying classified alloys, we're studying dust." Within days, access restrictions tightened. Data once open to international collaborators now required clearance tokens. A European researcher complained to ESA leadership that their JWST mirrors data disappeared overnight. ESA quietly appealed through diplomatic channels. Morales found herself navigating both science and politics. She wasn't alone. At JPL, radio astronomer Dr. Thomas Lee began analyzing microwave echoes from Goldstone's radar reflections of 3I/Atlas. The results were puzzling: a secondary glint pattern recurring every 11 hours, consistent with rotation but modulated by what looked like periodic flattening, perhaps a tumbling shape or uneven surface reflectivity. Lee shared his findings via an encrypted academic listserv, writing, "Shape irregular, maybe bifurcated, like a contact binary or joined fragments." Hours later, his message was quoted in tabloids under the headline, "NASA Insider Confirms Split Object." He deactivated his account the next day. Public interest reignited. Conspiracy channels called it proof of artificiality, science communicators called it noise. Inside NASA, communications teams drafted counterpoints while administrators demanded tighter information control. Morales's inbox flooded with requests for comment, which she ignored. Instead, she focused on something quieter: the signal baselines in JWST's telemetry. When she isolated the noise floor over multiple observation windows, She noticed faint periodic spikes recurring at intervals of roughly 43 seconds. They were below detection threshold, possibly electronic interference, but they persisted. She logged them as minor telemetry oscillation, unconfirmed. Her assistant joked, maybe it's Morse code. Morales didn't laugh. At AWS, Chen's team finalized their long-term resilience upgrades. But one network analyst, Carlos Vega, noticed something unnerving while reviewing archived logs. During the October incident, a diagnostic routine that pinged external NTP servers had received one anomalous reply packet containing unexpected checksum bits. It wasn't malicious, just malformed, yet the packet's originating IP traced to an unregistered subnet used for scientific telemetry near Maryland, the same area as Goddard. Vega flagged it as cross-domain echo. He emailed NASA's public contact form, received an automated thank you, and nothing more. Inside NASA, the message never reached Morales. Bureaucracy, like space, dilutes signals. On December 10, Morales attended a classified meeting at the White House Office of Science and Technology Policy. Representatives from NASA, the DoD, and the NSA sat around a long table. The agenda read 3I/Atlas, Information Coordination Framework. The tone was tense. A defense analyst asked bluntly, "Do we have any reason to treat this as a non-natural object?" Morales shook her head. "Not based on current data." "Then why is the public convinced otherwise?" another asked. "Because we keep saying no comment," she answered. Silence filled the room. A NASA administrator quickly shifted topics. "Our recommendation is a joint statement with the UN reaffirming natural origin and commitment to open data." The NSA representative muttered, "Open data gets you open chaos." The meeting ended with no consensus. That evening, Morales returned to Goddard and found a new email labeled High Priority. It contained a revised orbital solution computed by the IAA using new European data. The update showed a slight inward drift, less than 0.001 Australian dollars difference, statistically negligible but symbolically potent. She stared at the line of code representing trajectory curvature and felt the same unease from October. "It's not the numbers," she whispered, "it's the pattern." She didn't mean alien intent. She meant human repetition, the endless cycle of uncertainty birthing control and control breeding doubt. Around the same time, in a small office in Geneva, Favre signed off on a confidential annex to the IAA report. It included internal guidelines for potential non-terrestrial material analysis, drafted with input from defense liaisons. The annex stated, in the event of confirmed artificial signatures, data classification may supersede open access mandates under international security clauses. It was a bureaucratic footnote to history, unnoticed by the public but heavy in implication. Within the scientific community, fractures widened. A coalition of independent astronomers published an open letter demanding full release of JWST raw data. "Transparency is the antidote to speculation," they wrote. Morales agreed but couldn't sign. She was bound by contract. On December 14, the UN's COP session convened in Vienna. Delegates debated a new, interstellar contingency protocol. The U.S. proposed voluntary guidelines emphasizing verification before publication. China advocated for mandatory multinational oversight. Russia called for unified command in data handling. The motion stalled, but the very debate shifted norms. For the first time, interstellar object observation was discussed in the same room as national security. Back in Maryland, Morales received the first radar-derived shape model of 3I/Atlas. It was elongated, roughly 280 by 90 meters, irregular but solid. No obvious appendages, no symmetry. She felt relief, until her colleague pointed at a faint depression on one end resembling an impact crater or cavity. "Could be natural," he said. "Could be hollow," she replied. The model was too coarse to tell. Meanwhile, IceCube released another report. On December 12, a low-energy neutrino burst coincided with the object's reappearance window. It was likely background, but the coincidence stirred déjà vu. The data was published without fanfare, yet within hours blogs resurrected headlines: "New neutrinos detected during Atlas return." Public chatter reignited, scientists rolled their eyes. Morales drafted a rebuttal thread on social media, then deleted it. Silence is safer, she told herself. But silence was now interpreted as secrecy. Journalists camped outside NASA gates. A leaked internal memo from the IAA claiming data correlation under further study fueled fresh speculation. The Guardian ran a headline: "Officials still investigating Atlas connection." CNN followed, scientists tight-lipped as object brightens again. The cycle was self-sustaining. Inside the lab, Morales continued analyzing the faint 43-second telemetry oscillations. She eventually found the culprit: an internal power supply oscillation in the JWST cryocooler subsystem, perfectly harmless. She smiled for the first time in days, writing, resolved, instrumental. Yet outside her lab, the world had already turned those oscillations into myth. On December 18, a confidential interagency communication circulated among the DoD and NASA leadership. It referenced optical anomalies detected in JWST frame 20251218_134, described as glint patterns inconsistent with known cometary reflections. The attached analysis, authored by Sigma, concluded the glints were likely reflections from tumbling fragments. Still, the report was marked sensitive. Within 24 hours, a whistleblower leaked its summary to an anonymous blog. Fragments became debris field. Debris field became disintegration event. Within hours, #ATLAS breakup trended worldwide. Morales went on record clarifying, "No breakup observed, object intact." But the damage was done. Public imagination had outrun data again. By December 20, the pressure reached a peak. Favre convened a global teleconference with NASA, ESA, and CNSA. The decision: release all non-classified datasets before year's end to restore credibility. Morales welcomed it, though she knew it wouldn't stop rumors. Transparency was now both cure and accelerant. The following week, data torrents flooded open repositories: spectral cubes, polarimetric curves, radar cross-sections, light curves. Citizen analysts dove in. Some confirmed official results, others found patterns where none existed. AI models generated sensational visualizations claiming engineered geometry. Newsrooms picked them up without context. The distinction between data and imagination collapsed entirely. In the final internal report of December 25, the IAA summarized, 3I/Atlas exhibits continued non-gravitational acceleration consistent with volatile outgassing. Metallic spectral features remain unconfirmed. Trajectory stable, no collision risk. Public discourse volatile, confidence erosion significant. The phrase, confidence erosion, captured the real crisis. Science had weathered anomalies before. What it hadn't faced was a synchronized global feedback loop of fear, speculation, and governance paralysis. On December 27, Morales wrote her final note before year-end: "We measured everything. We explained most of it. But explaining isn't the same as believing." Her words echoed the private sentiment of many researchers. That night, she stepped outside the lab and looked up. The winter sky above Maryland was crisp, Orion bright in the east. Somewhere near the sun's glare, 3I/Atlas moved on its predetermined path, unbothered by classification levels or human doubt. The data would continue to arrive, filtered through instruments, parsed by machines, debated by committees. Yet the meaning would remain contested. Inside AWS, Chen's final report used almost the same tone: root cause identified, mitigations applied, incident closed. But his postscript read, human factors remain unsolved. Two worlds, astronomical and digital, had mirrored each other again. As 2025 ended, the mystery of 3I/Atlas seemed resolved, yet its shadow stretched into the new year. An object from beyond had passed through our sky, and in tracking it, humanity had exposed its own fault lines, the tension between knowledge and control, between transparency and trust. The final confidential paragraph of the IAA report, never published, read, "If 3I/Atlas is natural, we have learned humility. If it is not, we have learned something far more dangerous, that we may never agree on what natural means." What stayed after the silence? The first sunrise of 2026 over Washington carried no sign of cosmic disruption, no fiery tail across the horizon, just the same pale gold light cutting through a frozen skyline, and yet something in the tone of the city had shifted. The story of 3I/Atlas had left behind a residue, not of fear but of uncertainty that felt institutional, a kind of quiet hum under the surface of every press release and policy memo. By January 3, the IAA's final public report had circulated through every news outlet: object natural, trajectory stable, composition undetermined. It was the bureaucratic equivalent of a sigh. But the world had not reset, it had learned to live with ambiguity. Inside NASA's Goddard complex, Morales read the finalized datasets one last time. The metallic lines persisted faintly but without reproducibility, the radar shape remained irregular, the outgassing models fit within known parameters. She knew what the evidence said, it said nothing extraordinary, and yet the process of arriving there had exposed cracks far larger than the data itself. She opened her email to find a message from Chen at AWS, subject line, "Final closure." His note was short: "We fixed the code, but the pattern still bothers me." The same second, Rachel. The same second. She typed back, "Maybe that's all the universe ever does, echo itself," and then deleted it unsent. Outside, reporters still clustered near the gates, though the frenzy had cooled to background noise. They weren't chasing new facts anymore, they were chasing meaning. Morales, for her part, was done with meaning. She had begun thinking about leaving research altogether, maybe teaching, maybe writing about the sociology of science. "We don't study the unknown," she told a colleague over coffee. "We study how we respond to it." Across the Atlantic, in Geneva, Director General Favre drafted his resignation letter. The past 2 months had exhausted him. The IAA had survived, but barely. He wrote, "Transparency and trust cannot coexist when the public demands answers faster than data can form them." His deputy urged him to stay, arguing that institutional memory mattered more than reputation, but Favre's decision was final. He would step down quietly after the annual assembly in February. ESA, meanwhile, published a post-event audit of communication procedures, concluding that information latency magnified public speculation. China's CNSA released a detailed technical paper confirming independent detection of CO2 dominance in the comet's emission spectrum but emphasizing no evidence of non-natural material. Even Russia, usually skeptical of Western narratives, issued a terse acknowledgement: 3I/Atlas shows normal interstellar behavior. The consensus was overwhelming, and still, disbelief lingered. Online communities refused closure. AI-generated deepfakes of the object circulated daily, showing it splitting, glowing, turning toward Earth. A subreddit called r/Atlas Echo amassed 1 million members who called themselves signal listeners. They dissected every frame of data, convinced that buried within the telemetry was an encoded message. None of it was true, but belief itself had become the final anomaly. Within think tanks, sociologists began compiling what they called the Atlas effect, a framework for understanding how technical ambiguity mutates into cultural certainty. One report summarized it bluntly: in the absence of a definitive narrative, people create their own gravity. Universities launched new programs in science and public perception. Graduate students wrote theses comparing the event to the 1938 War of the Worlds broadcast, to the early pandemic misinformation cycles, to Cold War UFO flaps. 3I/Atlas had joined the pantheon of shared global hallucinations grounded in real data. Yet within the scientific community, a quieter transformation was taking place. Morales's team disbanded but left behind an informal network of researchers who called themselves the Open Orbit Collective. Their goal was simple: to make data open by default and interpretation transparent by process. They believed that the only cure for mistrust was exposure. If everything is public, there's nothing left to weaponize, one of them wrote. Funding was scarce, but momentum was cultural. At the same time, government agencies began implementing the very opposite. New policies classified space observation data that overlapped with potential national security interests. The wording was vague enough to include nearly everything. Within months, open-access telescopic archives that had been freely available for decades now required application forms, verification steps, and end-use declarations. The paradox was complete: the event meant to teach transparency had justified new secrecy. Morales watched it unfold with resignation. "We've built walls made of mirrors," she said to a journalist who came to profile her for The Atlantic. "You can see everything reflected, but you can't touch the truth." Her profile went viral under the headline, "The Scientist Who Refused to Believe in Panic." Meanwhile, AWS Chen received an invitation to testify before a new Senate subcommittee on infrastructure synchronization risks. The hearing was polite but hollow. Senators wanted sound bites, not systems analysis. When one asked him if he believed the outage was connected to the comet, he answered, "Only through timing, and timing is coincidence wearing a mask of meaning." The quote became a meme. After the session, he met Morales for dinner in D.C. They sat in a quiet restaurant lit by amber lamps, both drained from months of scrutiny. "We turned two unrelated failures into a mythology," he said. "Maybe that's what people need, a story." Morales stirred her coffee. "Stories survive data. And data survives people," he replied. "Sometimes." They didn't talk about it again. By late January, the world's attention had shifted to other headlines: political crises, economic fluctuations, a new exoplanet discovery. 3I/Atlas faded from front pages, drifting into the archive of things almost understood. But behind closed doors, a final set of analyses continued under quiet classification. Within the Sigma Group, a post-mortem titled "Residual Signatures" compiled every unresolved anomaly: the metallic lines that persisted inconsistently, the synchronized time drift, the radar glints, the faint 43-second oscillations, the ice cube neutrino coincidence. Each item was labeled either "explained," "likely explained," or "pending." Only one remained under "pending," a microvariation in the object's reflected polarization that followed a quasi-periodic pattern roughly matching the object's 11-hour rotation. It might have been light scattering off uneven jets, or noise, or something subtler. The report closed with the line, "Further study upon next interstellar object recommended." In other words, wait for the next one. At Goddard, Morales packed her office. Her resignation was quiet, effective end of month. She left behind a note on the whiteboard: "Nothing extraordinary, everything extraordinary." Her assistant photographed it and posted it online. It became the closing image in countless documentaries. Around the world, documentaries multiplied. Netflix released The Blind Window: How the Internet Fell When the Sky Turned, blending interviews, dramatizations, and eerie slow-motion shots of telescopes tracking nothing. It trended for weeks. A competing series on Apple TV, Echoes of Atlas, took a more speculative angle, suggesting classified findings never released. Morales refused to participate in either. Her silence became its own statement. Meanwhile, scientists prepared a paper for Nature consolidating the final data. Published February 10, it confirmed the expected 3I/Atlas's trajectory consistent with a hyperbolic inbound object, eccentricity 1.12, perihelion 73 cents, non-gravitational acceleration 2 × 10 m/s superscript 2, composition dominated by CO2 and refractory silicates. The concluding line read, while unusual in composition, the object's behavior remains within physical plausibility. Peer reviewers called it a masterpiece of restraint. The paper ended an era. The public barely noticed. But the final paragraphs carried weight among those who had lived through it. One phrase stood out: the event underscores the necessity of humility in observation and communication alike. Humility was the last unquantifiable variable. At the UN, COPUOS ratified the Vienna Recommendations on Extraterrestrial Data Governance, establishing an informal code for how nations should handle future anomalies: verify before announce, coordinate before classify, publish within 90 days. It was a small victory for science, a late concession to chaos. Favre, before leaving his post, signed the resolution with a weary smile. "We built a protocol out of confusion," he told a colleague. Maybe that's progress. As spring approached, 3I/Atlas receded into deep space, its path now traced only in equations and the trailing whispers of data. In late March, the JWST captured its last faint glimmer before it faded beyond the detection threshold. Morales watched remotely from her new office at a small university in Maine, where she'd accepted a teaching post. When the image loaded, a dim point of light barely distinguishable from background noise, she felt nothing mystical, only relief. "Goodbye, whatever you were," she said under her breath. But the story wasn't done. That same week, an independent research group in Finland published a reanalysis of archived spectra using an AI deconvolution algorithm. Their model reduced noise more aggressively and produced an artifact, a repeating harmonic pattern at intervals matching the object's rotation. They cautiously labeled it, likely mathematical artifact, but the internet labeled it, signal. Forums erupted again, headlines recycled old fears, and within 48 hours NASA had to issue another clarification: no evidence of artificial modulation. It was like a ghost refusing to stay buried. Morales ignored it this time. She'd learned that every clarification created new fog. Instead, she wrote an op-ed for Scientific American titled, "The Comfort of the Unknown." It began, "Our instruments are mirrors. They show us what we're ready to see." The essay was measured, poetic, quietly devastating. She ended with a single line: "Perhaps the universe isn't hiding its messages, we're just not fluent yet." It became her epitaph in the public imagination, though she was very much alive. Meanwhile, AWS incorporated lessons into infrastructure: redundant clocks, regional isolation policies, eye monitoring for configuration cascades. Chen moved into a strategic role focused on resilience modeling, often quoting Morales's phrase about echoes. He never spoke publicly about the outage again. For scientists, the event left a lasting technical legacy. Funding for interstellar object detection tripled. A new mission proposal, Sentinel-H, aimed to position telescopes off-Earth to avoid solar conjunction blind zones. IceCube began developing protocols for cross-domain event correlation, ensuring future coincidences could be statistically disentangled faster. The universe would keep sending rocks, humans would keep preparing. Yet beyond labs and agencies, something subtler endured. In coffee shops, forums, late-night conversations, people still mentioned the night the internet faltered and the comet shifted. Not as fact, but as symbol. It had become folklore, a modern myth of uncertainty. Writers, musicians, painters drew from it: a jazz album titled 311, a novel called The Mirror That Fell from the Sky, an art installation using synchronized clocks frozen at that fateful second. Each retelling blurred science into metaphor. And maybe that was the true aftershock. On the first anniversary, October 20, 2026, a small memorial livestream organized by science communicators and engineers brought Morales and Chen together again. They sat side by side in a quiet studio. "Do you think we learned anything?" the host asked. Morales smiled faintly. "We learned that data doesn't comfort us. Stories do." Chen added, and maybe stories need data to stay honest. The host asked if they still thought about the coincidence. Morales looked into the camera. Sometimes, she said, I think coincidences are the universe's way of teaching us to slow down. The stream ended with an image of 3I/Atlas's last recorded position. A small white dot on an infinite black field. Text faded over it, still moving. In that stillness lay the final truth. The world had not been invaded, nor enlightened, nor even particularly changed in material terms. But its perception of itself had subtly recalibrated. Trust in institutions had thinned, curiosity had widened, skepticism had matured. Scientists became communicators, engineers became philosophers, and the public learned, at least for a while, that the line between knowledge and belief is measured not in data points but in patience. Somewhere in the background hum of the cosmos, 3I/Atlas continued its silent trajectory, indifferent to every meaning projected onto it. And on Earth, the systems that had once failed hummed stronger, their clocks better synchronized, their operators a little more aware that perfection is a story, too. In the final lines of the internal IAA Chronicle compiled months later, an anonymous author wrote, "We watched a visitor pass through our solar system and discovered that it was not the object that bent toward us, but our own reflection bending toward it." That sentence was never published officially, but it circulated quietly among scientists as the truest summary of the entire episode. The comet faded, the internet healed, and humanity, restless, curious, unsteady, kept watching the sky, waiting for the next anomaly, the next blind window, the next chance to misunderstand the universe and, in doing so, understand itself just a little more.